Hey guys, welcome back to the channel. This is part two on the 2004 F-150 Lightning supercharged with the Purge valve solenoid circuit now working properly on the PCM, not fully grounding the circuit. Right, so I'm going to give a very extensive test showing in here so you can see now the computer working 100%. For those that have not seen the first part, I will put the link on the description. So please go ahead and watch that one. You will see how the circuit, when the computer is on, it was just barely going into 200 and something or so milliamps when these two test lights are connected. So just to save time on the video, I have everything ready to go. The computer is on and ready to talk. I can actually turn this off and you will see how the test lights are now on and they're drawing higher amperage than before, which is just normal. That's just a wake you off. And in this is no battery, no keep alive power. So the normal stage of the circuit is closed until you put the ignition on. Right, so when the ignition on, the lights goes off because obviously it's not being actuated. Uh, Again, for this, I'm using the top-down Finis Max. It's very capable scanners. I have bidirectional controls. It's a really, I'm very happy with the scanner. So again, this is the computer. I have also connected picoscope. The blue channel is connected to pin 56, which is the actuation of that purge valve. And then through an multimeter set up into amps. I have the one side going into the other side of the test light. So it's the ground side connected to the pin 56 and then power coming through the other side through an amp meter and then voltage being supplied. For this one, I'm using my other bench supply. This one can supply up to, 50 amps. And the mode that I have for the 4 millimeter banana adapters, I can provide up to 10 amps. So this is very capable. And this is the reason I'm using it. So before I proceed, let me start the screen recording so we can see more. All right, guys, I got the screen recording going on. The reason I'm doing that is because, well, I want to show you these tests also right here. This is an Identifix. So again, this is the vehicle that we have talked. Identifix has a very good test. If you like to or are part of this, you can see this test that also show you what the resistance of the canister purge solenoid should be and when the amperage, maximum amperage should be in between 300 and 400 milliamps. Actually, this circuit is capable of handling up to 1 amp. And here, if you click in here, there's actually a test that you can see. P0443, and we've already put everything in the code keep set. So what he is showing in here is just a basic test to disconnect the PCM uh, connector, again, this connector in here, go over to pin 56 with everything turned on. I already showed this on the first video that the power side of um, the power side for that evap canister valve is actually on, has a voltage that is hot all the times, and the actuation of the relay that controls the power is just with the ignition on and run or start. So you will have power in there. So what he's showing in here is to disconnect the computer connector, as we see here, right? Disconnect the computer connector, find the pin 56, and then just ground the circuit. And then through a through a multimeter or an amp clamp, like I'm doing in here, you can measure and see how much is the draw of that valve. If that valve is drawing more than what uh, it should be, then you have a problem in the valve. But if you can now ground it completely, actuate the valve on and off, and it's in a healthy amperage value, then the problem is in the computer. That's all you need to do, right? So right at the computer connector, you can check the entire circuit. Just use of an amp clamp and then a ground wire on pin 56. Again, the reason of using an amp clamp, you already have a fuse in the circuit, so you don't have to be afraid of doing anything. I will recommend to check with a with a multimeter before you use a ground in pin 56. So make sure that you are not having power in there. Although you're gonna see voltage with the evap canister connected because it's going through the coil. So disconnect the canister purge valve, and then with the computer main connector disconnected, check, make sure it's not short to ground or short to power. If it's open, right, which it should be because you got the evap canister disconnected, purge canister disconnected, and the computer, it should be an open wire, right? That's it. But if you check that, you can now connect back the purge valve and do the test with the ground, and that is a valid test. All right, that's all I wanted to check here. This is a really good test. Identifix always is a very good information. All right, the next thing that I want to show is before the repairs. This is the values that I was getting on the actual circuits. So blue channel, again, is connected to pin 56 with the test light and everything you see here. And then my red channel, I am using it on the circuit right here. This is the driver in control of the purge, sorry, right here, of the purge valve. If I go over to the pin number, let me just remember, I think it's pin 3. We'll see in a second, yeah, but I think it's pin 3. That is what I'm seeing in there. And I was commanded the purge solenoid 50%. And with 50%, I put, a match channel right here at the bottom to see what the negative duty cycle was, and it was 48%. Again, maybe my rulers are not 100% in the spot, but we can see that we have something like that happening on the blue channel. Again, pin 56, but it's only coming down from 12.86 to 12.28. That's not enough to pull the circuit down, even though the control is there. So definitely it's not just the driver and the pre-driver, is the entire circuit that it has a problem. So this is exactly what I'm trying to show here. So what I'm going to do now is I'm going to run the test. Let me remove all the glare or crowded things on the screen. So I'm going to put first, we have 13.4 volts on blue channel. Again, no actuation, so we just have battery voltage, right? So I'm going to go into the scanner. We're going to select the percentage. You're not going to do both tests, so you will see both tests going on. I also want to share or show you. I can select in the data stream. Just go over to the evap. Uh, it should be already selected. So these three are evap emissions, vapor management valve, percentage, and then fault. We see got no errors. All right, so we're going to go to 10%. Come on. I lost connection. Has not been met. So let me just go back. Sometimes it says that. I don't know why. Everything is connected. Yep. Stream. Okay. See, now it's working. All right, so we can see immediately in the screen with just 20%, a very big difference on the signal. We went from 13 and we're now into the high peak around 10 volts, 10, 15 right here to the lowest 4 volts. If I snap this on the screen right now, so what we have to take in consideration is not just that we are going, what the duty cycle of this like sawtooth thing in here is also that we are now at lower voltage because we went from, 13 something and we're now into 10 to 5, right? So in order to keep these bulbs or the solenoid working at 20%, the voltage is going down, and then to hold it there at that 20%, right, that we have here on the scanner, right, the voltage has dropped, and then to keep it there is sending a pulse width modulation. So the computer is in full control of that. What I want to show, and yeah, that's just the way it works, is that duty cycle is not going to work here because it's just not just that, right? So let me go over to pin 3 here, and then we will see that we have indeed the actuation, right? So I can it's recording in second waveform, they were form. I'm going to stop the screen. All right, so I can now release that and then stop it. And in here is where we can actually see the pulse width, because this is the signal that is really being pulsed. And here we can really calculate how much is the computer sending that signal to be uh, pulsed. And then we can put the match channel, not match channel actually. Let me just get a measurement, sorry. And it's going to be in the red channel. We can calculate in this case is actually, it looks like it's a positive cycle. So let me just find it. I don't have my glasses on me, so just bear with me. Positive duty cycle. Hold trace between the rulers, 20%, exactly. So perfect. So we can now see that is exactly how we can see it. That is there. So on pin 3 of the driver, we have exactly the 20% of actuation. So I'm going to go over to 50%. And we can now immediately see the big difference. Now the amperage is also bigger. This was never going over 200. I mean, and 50% on, I'm actually in 60. Let me go down to 50. Yeah, on 50% before it was around like 114, and the light was really dim. So this is 100% fixed. All right, so I'm going to now run again the capture. We can see there, and I'm going to go over to again pin 3 in here. I'm using the red channel for that, so I'm using the microscope so I can see very well. All right, so we're going to just, you can see the signal change, and I know that you guys are seeing in that. So again, I'm just in pin 3. I'm going to let it go again, and then we can stop that capture on the screen. All right, so now if we measure before wasn't 20%, if we measure now, so we're going to go to positive duty cycle. We have to probably go from here to here. Yeah, 50%. Okay, so that matches exactly what we got. Like I said, we're measuring and we can see the now, and if we see now the actuation is matching the blue channel as well. You see? So before I was trying to capture in here, I should go over to the upper picks into that, but it's working 100%. So if we go over now, I'm just changing here. I want to go over to 90%. Now we can see, I mean, look at how bright is that, and look at the arm draw. Again, let's do this capture again one more time. If we see now, look at the big difference now. Okay, 90%. Oh, sorry, I mean 100%. Sometimes it gets pressed by itself. Now we're in some duty cycle, and I'm going to capture that one. And I'm going to show you how difference of the signal. Hopefully you guys have been seeing the entire thing. All right, so I'm in both captures in there. I think that's good enough. Let's just stop that and go back to the last screen. And we're going to do a zoom in here. We can definitely see the huge difference. Now, if we put a measurement, let's grab the rulers again from here. Well, we can do from here to, let's see, the upper edge. We're looking at right there. And then we put the next one here, right? Nice thing about Pico is even give you what should I call an example of how do you have to do it. So this one is showing us 82.41, close enough for what I'm doing, 90%, no errors, and we can see the lights very nice and bright. This meter just went off because of timing. But yeah, it's definitely matching the blue channel. And now I want also to show you is where is now the blue channel at. We're now in 4 volts at the peak and then at 2 volts at the bottom edge. If we go over to 100%, we're probably not, I mean, not probably, no, we're not going to have any pulse width. It's just going to be a signal steady, right? Because it's now being commanded 100%. So it should be no pulse width. So if we uh, touch now the red channel, I mean, pin 3 here, I am doing it now. We can definitely see that it is just on, right? So no more pulse width. It's on, and let's take a look at the voltages. So it's just going to stop it right there. We will see that in the capture. Perfect. So now we can see that now the blue channel is around lower than that. I will say probably 2.78, and then the red channel is just fully activated 5 volts, right? 4.83. So yes, this is 100%, and then when I cancel this, obviously lights should go off. Up. Let me just get out of here. Lights go off. No arm draw, 100%, and then everything is working. So I hope that you guys see the value of testing before and after, so you can reproduce and show the customer that indeed the computer needed repair, and actually you did the repair, because not many other facilities do this. I have sometimes customers, tell me, Mike, your labor is higher or your price of the repair is higher than anyone around. I'm like, yes, I just don't compare my labor with anyone around. I don't see anyone showing you what they're doing, and are they really doing it? Because I am not afraid to show what I am doing, because I am actually doing the repair. A lot of facilities, they're just sending you a used computer from the junkyard to see if it works or not. They just put the VIN number, send you another computer. Oh, it's now doing worse. It has some other issues. Okay, well then later, or finally, if you're lucky, they refund the money. But yeah, so I'm not that way. I like to test. I am a data analysis person. I take always my captures, check everything, signals, mapped out the entire computer, and then give you the recommendation based in knowledge, based in testing, so the computer will be fixed. All right, Kenneth. I hope that it's not a super long video. Let me stop the screen recording too. We don't need this no more. But yeah, as you guys see, everything is now working properly. Everything is 100%. All right, let me just, now my fingers in the screen. Sorry about that. I just want to, close the video and say thank you so much for visiting the channel. I'm really happy for all the still stay with me and are, supporting the channel, making questions and comments. I know that this might not be so interesting at other channels that are just doing, I mean, more fun stuff. I am, again, more technological and repairs, and this is what I love to do. So as in the mechanics, I do a lot of repairs on European vehicles, and now BMW, Mini Cooper, and Rolls-Royce, and that's what I like to share. All right, guys, thank you so much. See you next time. Bye-bye.